This is Mr. Beck Does Your Homework, AP Physics, homework number 6.3, question number 4. A 0.28 kilogram bullet, a 0.028 kilogram bullet is fired vertically at 312 meters per second into a 0.13 kilogram baseball that is initially at rest. How high does the combination rise after the collision? What we sometimes have is a conservation of energy problem when we have something like this. But here I've got two objects involved. So this bullet is flying along at 312 meters per second. It's going to embed itself in this baseball that's sitting there. There's my nice strings on the baseball. So it's going to embed itself in the baseball, and then the combination is going to rise up some height with the bullet stuck in the baseball. Okay? So this is kind of what I'm dealing with. So here, when I have the bullet hitting the baseball, this is a momentum is conserved problem. And then once it starts to rise, then when it rises, now I'm going to start off with some KE here, and it's going to equal PE when it gets up to the top. So here I'm going to have energy is conserved. But I can't say energy is conserved overall because I'm going to lose some mechanical energy in this inelastic collision when the bullet hits the baseball. So first let me do my momentum problem. There I have a bullet that's moving at some velocity, and it's the only thing that's moving. So I know that that's going to be in my sticky collision, the bullet plus the baseball moving at some new velocity. So here I've got the mass of the bullet is 0.028. It's moving at 312. That's going to equal the bullet plus the block, 0.028, plus, not the block, the baseball, 0.13, moving at some velocity. Now that's going to give me the velocity of the bullet and baseball moving together. Now I've got an energy is conserved problem. So here's that's my momentum problem. Now I know that the bullet and the baseball are moving along at some velocity. That's going to give me a KE at the bottom. KE at the bottom is going to be my PE at the top, because here energy is conserved. So here I've got 1/2 mv squared equals mgh. Look, the mass cancels out, so I don't even care about the combined mass anymore now that I know the velocity. So I've got 1/2 v squared equals gh. So my h is going to be v squared over 2g, and make sure that you're using g as 9.8. And that'll give you the height at which the baseball and the bullet will rise to. So I've got momentum conserved over here and energy conserved over here.